right. My name is Sami, um, Ghana at Ghana Telecom University. All right. So what I'm coming to build today is that's 3 by 8 decoder. 3 by 8 decoder. So when you look on the sheet of paper, this is um, the calculations, or this is how I have structured it before I bring it on the PC. Okay, this Logism software. Okay, so before that, I just work on it before I'll build it. All right. Now, um, with this decoder, it has three input. Okay, three inputs, and decoder is actually or normally talks about the number of input that correspond to the number of output. So if I have, or let me explain, like a decoder is a multi-input and multi-output logic circuit which decode n input into the square of n. Okay, so that is decoder. So that means that if I have two input and the output is going to be 4. Okay, so if 2 is equal to n, all right, if 2 is equal to n, right, so I'll have 2, that's 2n right now. So here, if it is equal to 2, I may have 2 to the square of 2, right? That give me 4. So that means that if I have 2 as input, all right, and the output is going to be 4. If I have 3 as input, all right, so here the going to put 3 here, then I get my 8, right? So if I have 3 as input, I'll get 8 as what as output. So for decoder, normally talks about the number of input that correspond to the number of output. All right. Now, since I have 3 input here, I also have what is called enable. So that means that if I enable this, and it gives the access of it gives that coder access to allow those that are activated to reflect or to work. If the decoder or if the enable is off, that means that it is not going to allow it to work. So imagine I have my decoder is off here. Okay, that means that it doesn't have any signal here, and therefore I'm going to be receiving 0000 here. So I would not have as, or it will not even come. But since it is enabled here, that means that I have given it access for it to work based on the number of output that is selected. All right. Now, if I have an input, okay, A, B, and C, all right, then I have the output as I7, I6, I5, up to I0, up to I0. Now, if I have 000, these are the binary indicator, the binary values here. So I have 000 here. Now, since it is 0, then I need to actually make this one activated since it is what 0. Okay. Now, let me cancel this one. Well, let me write it well. 1. Now, this is 1. All right. This is 1. So that means that here I have to make sure that I have one word binary here. Okay. Now this is 2. Okay. 2. The reason why I am getting those values is that if I want to find uh, the decimal number for maybe 10, the binary number for maybe 10 here. Okay, this time I'm going to do it. I just have my 1, 2, my 4 here. Okay, and I have my 8 here. So here, how would I get the 10 or convert it to binary? That means that I have 8 here, I have 2 here. 8 plus 2 is going to give you what? 10. Okay, so here it be 0, here be 1, here be 0, here be 1. So 10 to binary is going to give you 1, 0, 1, 0. That's the same way if I want to convert maybe 1 to binary. Okay, or 1 as a decimal to binary, I have is equal to 1, right? If I want to convert 7 decimal to binary or to base 2, okay, this I'm going to do it. I have 1 here, I have 2 here, I have 4 here. Now in this case, how will I get the 7? So I'm actually going to add this one, and add this one. Okay, 4 plus 2 give you 6 plus 1 give you what? Gives you 7. So that means that here's 1, 1, 1. That's the reason why here I got 1, 1, 1. What if we are talking about maybe I3, that is 1, 1, 0. Okay, how did I get the 1, 1, 0? Because it is 3 here. Okay, now let me convert this decimal to binary. So here I have 1 here, I have 2 here, I have 3 here. Okay, so it is 3. So how would I get it? Okay, so here I have 2 plus 1 give you 3. So here is 1, right? Here is 1. Okay, this is what? 0. Okay, that's the reason I have what? 0, 1, 1. Okay, 0, 1, 1. So this is how I got the binary for the decimal. Okay, so in this case, I have all the values from here. Okay, I have this one, I have that one. So I have all the binary that correspond to the input and the output system here. Now, since I have the truth table here, now I also work on the Boolean function. Okay, so if I have y7, that means that this one is 1, 1, 1. Okay, y6. Okay, or I6. Sorry, I made it instead of I made it y. Okay, so they are all what? I. Okay, I, right? I. Okay, I, right? Very good. Now, this one here, I5 here is what? Is 101, right? I4 is what? 100, right? I3 is what? That's 011, right? I2 is what? 010. I1 is um 001, and I0 is what? 111. Okay, 0000. That's how subtracted it. All right. So in this case, I'm going to now work it or draw it on the computer. All right. So let's move to the PC and let's start designing the 8 by 3 by 8 multiplexer. All right. All right. Now I'm coming to build the 8 by 1, a 3 by 8 multiplexer here. 3 by 8 decoder, sorry, decoder. How do I build a decoder? Now, the decoder here is built based on the number of input that correspond to the number of output. Okay, so now I have 3 input as A, B, and C. Okay, so here I have my A here. Okay, so let's have my A here. Okay, so let me close this one. So I have this is my A here. Okay, this is my B. All right, now this is my C. Okay, so let me label it. uh, Let me write something here. I don't even know how to write it here. Okay, how should I even put it? Okay, all right, so well, so this one is A. Okay, don't know if I should. A. Oh, okay, so this one is A. Okay, this one is B. B. Okay, this one is C. All right, yeah. Okay, so I believe I can. I don't know if I can bold this one. Well, so I have A, B, and C as my what do you call it? Eh, very good. Okay, now I have AB. So the second one here. Now let me construct my output. Okay, my output. For this one, it has the input as 3 and output as what? As 8. Okay, so how do I construct this one? And it is very, very easy for you to construct this one. Okay, now the only thing that makes this difficult is when you don't actually understand what you're doing. Okay, that makes it something. All right, so now I have to get my 8 output. Okay, this one is the input. The ABC is the input. So I have to get my 8 input, right? So I have one here. Okay, I have one here, right? Now this one should be 3, right? Now I copy it. I have 2 here. I have 3 here. I have 4 here. Um, I have my 5th number here. Okay. Okay. I have 6 here. I have 7 here. And I have the last one that is 8. Okay. 8. Okay. All right. Now, how do I combine it? Now here, I'm going to construct my lines. Okay. My lines. So I have this one is, let me label it. Okay. This one is D7, right? I label it as I7. I7, right? A I there. I7, right? I7. Let me make it D7. Okay. D7. Okay. So here's going to be D6. Okay. I have D. Yeah, D5. And I have my D4. I have 53. Okay. D2. D1. Last one is D0. All right. Now, since I've labeled it, now let me draw my lines here. Okay. So I have my lines here. So 1, lines here, right? Let me have my NOT gate here. All right. So I have my NOT gate here. Okay. Mm-hmm. Mm-hmm. Okay. Since I have my NOT gate here. All right. So I can bring this one down small. Then I stretch it forth, right? So here, have it here. Mm-hmm. All right. So here, I also have my that's my connector. I connect them here. All right. So now I have my 1. Okay, I have my knots. I have 1. I have my knots. I have 1. I have my knot. Right. Left with this one. Okay. Now, all right. So I think I can. Um, I think I can even. Oh, I can push it small. Okay. Now I have my point here. I have my output here. Okay, I have my output here. Out. So it's becoming nice, eh? I have my output here. All right, so after it, I get my pin. Okay, that's my output. Okay, I have it here, right? That's V here. Okay, all right. So that's how I'm constructing it. Now I have to get my enable. Okay, my enable should be somewhere here. All right, I prefer to put it here. Okay, so that's that one. If it is enabled, that means that now it is actually going to work, right? So I have it here. This is my enabler. So anytime this one is switched on, that means that my decoder will actually work. Okay, so this time I'm building my decoder. Now this decoder, all right, so let's continue. Now I have my one here, I have my one here, I have my one here, right? This is zero, this is also zero, this is also zero, right? Now I think I'm actually doing something small. Okay, so I'm going to connect it based on the, so I'm actually going to use my calculation, okay, the binary or the truth table to implement what I've done here. So I'm going to start with the D7, this one, the D7 here. Now the first one that I have here, okay, I'm actually going to connect it to, so I have A, B, and C, okay, this one A, B, and C. All right, since I have this one, I can make it, let me make it 4 so that I have my connector here. Okay, all right, so let me make it here so that our enabler can come. Since I make it 3 ports, I don't think it's just going to work. So here, make it 4. All right, so here the first one going to, this one is A, this one is B, okay, okay, and this one is C. All right, that's D7. Very good. Now the next one is how do you call it? The D6 is actually A B. That's 110, 110. So that means that this is 1. Okay, 1, 1. Okay, and the next one is 0. Okay, so here I'm done with it. Now let me connect it to the enabler so that I don't come back to do it again. All right, so this one is enabler. All right, now the next one is here. That is if D5 is 101, 101. So here is 1. The second one is 0, and the third one is 1. Okay, then let me connect it to my enabler. This one is purposely there so that the moment it is activated, that means that the AND gate or it should be working. Okay, now here the D4 is 100, right? So here I have my 1 here. Okay, 00. So here is 0. Okay, 10. Oh, 1 0 0. Okay, so then my connector. All right, a D3 is 0 1 1 0 1 1. So here 0 0 1 1. So 0 1 1. Okay, let me connect it here. Very good. Now D2 to 0 1 0. Okay, so I have 0 1 0. So yeah, 0 1 1 0. Okay, so let me connect it. Now the next one here, that's my D1. D1 is actually going to be 0 0 1 0 0 1. Okay, let me connect it. Right. The last one is that's 0 0 0. So here is 0 0 0 0. Okay, and I connect it to my this one. Now let's see. Now that I am done with it, now let's see if it's working. Okay, if it's working. All right. So here. All right. So since now I'm going to make sure if it's so this enabler. All right. Let me write it here. Okay. Enable. Okay. So enable. So let me write it here. Enable. Right. Good. So enable. So this one, the moment I enable it, that means that it is actually going to work. All right. So if this one, I enable this one here. Since I have 0 0 0 0, let me see if this one is activated, right? It's activated. So this is enable and it is working, right? Since I have 0 0 0, okay, 0 0 0, then this one work. If I have, so let me look at the next one. I have the D, this is D7, the D6 is, this is 110, right? 110. So I have 1 1 0. That means that it is working. The D6 works. Now, if it is 0 101, that D5 is 101. 1 so we have 101. That means that this is also working. Okay. So if I turn on off this one, it goes off. If I turn it on, it is activated. All right. And last but not the least, here I have so it goes on. So for reference sake, let me make sure all works. Then I end my video. All right. Now the next one is 100 100. So I have 100 and my D4 is working. Okay, my D4 is working. Right, it's working. It is working. Correct. Correct. Now let's see the D3. Okay, D3. Let's see how the D3 is going to work. Now, my D3, how will I make my D3 work? Now, when we work on the binary or the truth table, realize that the D3 has a very that's 0 1 1. Okay, so let's make sure this one is 0. Okay, we have 1 and we have 1 here. See if our D3 works. So, yes, now the D3 works, right? Now we see the D3 works, right? Now it works. Okay, now let's work on the D2. How will I make the D2 work? D2 is what? 0 1 0, right? So this is 0 1 0. Okay, now the D2 works. And the D1, okay, the D1 is actually 0 0 0 0 1. So 0 0, this is 1, right? So that means that it starts work. Okay, it works. This is a decoder. The decoder is the opposite of multiplexer. All right, and the last one is actually 0 0 0 0. So this is 0 0 0. So that one works. Okay. So thank you, sir. This is my decoder. That is 8. Let me write it bold here. So that's 8. Okay, 8 by 8. 3 by 8. 8 decoder, right? All right. So okay. So I've started something small, but the 4 by 16 multiplexer.
Yeah,
Right.
multiplexer.
A decoder. 4 by that's the 4 by 16 decoder. All right. So yeah, let me name it. Okay. So let me actually name it. So this is going to be D. This side going to be D. Okay. So I have what is called a D15. Okay. D15. Right. So the same way as D 14, D13, D13. That's D12. Yeah, D12. Okay. This one is D11, D10, right? D10. And this one is also D9, D8, D7, D6, D5, D4, D3, D3, D2, D1, right? And D0, right? D0. D0. Now this one is called the enable, right? So here is the enable. Okay, and this one is so I'll name this one A. I'll name this one B. I'll name this one C, and this one is D. That means that, right? Yeah, that's how it is, right? Okay. All right, so let's move on. Now, I just have to connect it. This one is the D14. D14 here is 1110. Okay, so we have 1110. So this is 1. Okay, this is 1. This is 1. The last one is 0, right? So here is 0. Okay, and I connect it to the enable, right? Now the D13. Okay, D13 is also 1101. 1101. Okay, so this is 1 1 1 1.
Is that say what I made the show of him so let's say
Okay, me 1101. Okay, 1101. Assignment.
hello.
1101.
I don't know hello no.
Alright. 1101, 110. So this one is
I do
1101. So 1101. This one is 1, right?
Oh, and let's see how good me.
1
Ah.
1 1 1 So 1 1 1 1 0 0 1. Right? Let me bring it here. So this is 1 1 0 1. Right? So I'll connect it to the enable, right? Or the enable it. And the next one is 1 1 0 0. 1 1 0 0. So 1 1 1
Oh, cross into kutukuskototom.
1 1 0 0. May I record now where did this? Okay, so this is 1 1 0 0. 1 1 0 0. The next one 1 0 1 1. Okay, so 1 0 1 1. So 1 0 1 1 0 1 1 0 1 1 1 0 1 1. Aboa. Then this one is going to be enable it, right? Good. Now let me even see if something is working here. All right, so enable. Okay. All right, I think something is working here. Okay. Okay. All right. Let's continue. Right. So the next one is um. So we are on D10. 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 D10 is 1010. 1 1 0 1 0 1 0. Then I connect it. 1 0 1 1 0. Right. Hmm. 1 0 1 0. This is working. So let me turn it off. Let me turn everything off. Right. Very cool. So the next one here, 1010 says 1001 1001 1 0 0 1. All right. The next one is the D. This one is D. Okay. So D8. D8 is A. I think I'm D. Yeah, D8. D8. 1000. 10000. 1001 1 0 0 1 1000 1 is 1, 0. Zero, one, one, zero. Ah, Taya. Woo. D6. D6 is, so this is the 0110. 0110. So this is 0, 1, 1, 1. Oh, Jesus. D5. 01, 01. 01, 01. 0, 1. Zero, 1, 0, 0. 0, 1. The next one is 0011. That's D3. 0011. 0011. 0, 0, 1. Zero zero one one. Ha. The next one is 0011. 0010. 0, 0, 1, 0. All right, I'm done. So I'm now coming to see to it if it is activated. All right, so this is from D0 to D15. Okay, D0 to D15. I wish I could even bring this one here so that I'll actually have, okay. So this is it. So let's activate it. Um, so this one is turned on. Okay, it's turned on. Now because it is turned on and it is 0000, okay, I can see that my 1x activated. This one is activated. So that means that here, if I click here, if I enable it, okay, it works. All right. Now 0001, okay. The moment this place becomes one, right, then it becomes activated. Okay. So here, all right. So the next one, the moment this place become one, okay, becomes one, right? So it's actually working, right? Okay. So if this place become one and here becomes zero, that means that the third one works. All right. Good. If here becomes zero, okay, and this place becomes zero, right? It works. All right. So everything is working here. 1101, right? That is the D13. All right. So this is how I've built my 4 by, okay. So okay, so this is that's 4 by 16 decoder, right? All right, that's how it is. Okay, um 4 by 16 decoder. Thank you very much.